Hello and welcome back everyone. Today I'm going to introduce the 6 basic trigonometric functions that are considered to be the core of trigonometry, widely used in many fields for countless applications. The following trigonometric functions are the cosine, the sine, the tangent, cosecant, secant, and cotangent, all abbreviated as follows. These set of functions center around a right triangle and right triangles only, in which we're studying a random angle and the measure of each side of the right triangle, such as in this case. For instance, let's say we have this right triangle. We have this side is 3, this side is 4, and this side is 5. And you can confirm that using the Pythagorean Theorem. And I have a video for that in case you need some review. And let's choose this side to be the angle we're focusing on. And let's label it X. So, one thing you should keep in mind is that written next to each trigonometric function is the ratio of the length of the two sides of the triangle. Now, before we begin using these functions, it's important to know the measure of each side of the triangle before proceeding with the problem. And it's also important to determine which side is which in reference to the angle you're studying about. So assuming we have a right triangle with these sides, and assuming we chose this angle right here, the opposite of this angle, OPP, is how it's abbreviated. The opposite of this angle will be 3. So 3 in this case will be the opposite side of the angle. Now, adjacent to this angle, which is going to be 4, we're going to write ADJ for adjacent. And then the hypotenuse, in this case, is going to be 5. Now, since we labeled each side and we know each length, now we can proceed with the trigonometric functions. Now, we're asked to find the trigonometric functions, all 6 of them, using this right triangle. So, for sine x, since it's concerned only with the opposite and the hypotenuse, you're going to look at the angle in which you're studying about. You're going to choose 3 as the opposite over 5, the hypotenuse. So 3 over 5. And that's it. For cosine, we have adjacent over hypotenuse. So in this case, it's 4 over 5. For tangent, tan x, we have opposite over adjacent. So in this case, it'll be 3 over 4. Sorry. Opposite over adjacent, 3 over 4. Yeah. Now, for cosecant, secant, and cotangent, notice how if you look at what sine stands for, what cosine and tangent stand for, all of these ratios are flipped. Basically, they got the reciprocal of the sine, put it under 1. So basically, let's say we have opposite over hypotenuse, which is the sine. All they did was they divided opposite over hypotenuse, 1 divided by opposite over hypotenuse, which is going to give us hypotenuse over opposite, which is what the cosecant is here. Now, go ahead. Starting with cosecant, we have CSC, or cosecant, is equal to hypotenuse over opposite. So 5 over 3, the exact reciprocal of the sine. 5 over 3. Now we have the secant, secant x. And it says secant x equals hypotenuse over adjacent, which is 5 over 4, the exact reciprocal of the cosine. 5 over 4. And then for cotangent, cotangent x, it's adjacent over opposite. So 4 over 3, the exact reciprocal of tangent x. So that's it for these 6 basic functions. In later videos, we're going to look at inverse functions, which are a little bit different. However, a lot of the principles, a lot of the basic principles are the same. Of course, this method can apply on any right triangle, as long as it's a right triangle only. One thing I want to mention though, however, is that notice this angle right here. So we chose this angle to be the angle we're studying. If you're not consistent with your angle, or with the angle you choose, you're gonna end up with a lot of mistakes in your math down here. For instance, let's say you choose this angle to be the angle you're studying. So if you wanted to get, well, first of all, let's try to label the sides. Now the numbers don't change. This still remains to be the hypotenuse, since this is the biggest side. This, however, is going to become the adjacent side, since this is right next to the angle. This, however, will become the opposite side. So I can go ahead and erase this, and I'll write opposite, and write adjacent here. So if you were to find, let's say, the cosine of this angle, cosine stands for adjacent over hypotenuse. So it'll be 3 over 5. 3 over 5. Notice how cosine here is not 3 over 5, it is 4 over 5. And that is because we changed the angle that we were looking at. If you choose this angle, everything is going to change too. So mainly, bottom point, you just have to be consistent with the angles that you choose. Also, another way to, a way to remember all these trigonometric functions, one thing you can do is that there's a phrase that I'm sure a lot of you out there know it. However, in my school, they taught this to us, I believe sometime in high school, correct? And this is what they wrote for us. So, ka, toa. This stands for sine, cosine, and tangent. We have sine, cosine, and tangent. These letters correspond to the sides of the triangle. We have O for opposite, H for hypotenuse, and A for adjacent. So sine would be opposite over hypotenuse. Cosine would be adjacent over hypotenuse. Tangent would be opposite over adjacent. And of course, if you memorize these, you can easily figure out the cosecant, the secant, and the cotangent. All you gotta do is just flip those letters, or write them out and then flip them later. But that's it for today. If you have any questions or concerns, please leave a comment in the comment section below. Thank you so much for watching. Please go ahead and give this video a thumbs up. Subscribe to my channel, please. This is going to help grow the channel more, and we'll see you in the next video.